Our speaker this evening has over 20 years of industry experience. Please welcome the solution architect for Basho, Craig Vitter.
Thank you. I appreciate that every time. It's good to be here. That is a great number. So thank you for coming. This is a really packed room. And I'm terrified because I don't actually like public speaking. So if I start to sweat, people in the front row will see me turning down. But you guys already know the title, Easy Time Series Analysis with Riak TS, Python, Pandas, and Jupyter Notebook. So what we're going to talk about is what time series means, and hopefully we can come to some kind of agreement on that topic. What Riak TS is, and this is very exciting for me specifically, how you do things like create tables in Riak TS, how you populate those tables with data. Mike's dying. Mike's dying? Swap it back. Okay, so I already killed the mic. That was a really good start. I'm good at killing things. Another skill. We're going to do some querying, and then we're going to do some visualizing queries, and boom, we have done data science. Show of hands. I'm sure there's at least one. Who is a data scientist in this room already? There's some of you, you're not willing to like really admit to it. Come on. If you're a data scientist, okay, I am not a data scientist. I am going to admit a dark secret. I have a degree in art. It is true. That is what my degree is. I have a degree in art. Concentration in photography, in case you're curious. And the reason I'm admitting this right now is for those of you who did not raise your hand for the Are You a Data Scientist, it is amazing how much you can do with these tools without actually having to be a data scientist or having the term data scientist on your business card. I think when we're done with this, hopefully you all agree. It isn't that hard to do some really amazing stuff with the tools that we have available today. So what is data science? Or what is time series? Time series is usually some kind of structured data that is specific to a point in time. So log file entries, who's intruding on your routers, who is visiting your website, weather data. If you go and look at weather on your phone, that's time series data. It's a point in time snapshot of what the weather looks like in a specific part of the world. Patient vitals. Anybody in the medical industry here? No medical industry people? Oh, people are really shy about raising their hands. Nobody wants to admit what they do for a living in this place today. Tidal measurements. That's actually really important data, right? Sensor data. You can see there's some really common use cases that are considered time series. But what does that mean? So basically, data captured a specific point in time, and you want to do some analysis over a time range on that data. Like how much did the tide change in a given time frame? What's the person's heart rate over a course of a day? And is there any kind of correlation for time of day, what their activities are during that time of day? So that brings us to Riak TS, because Riak TS is a time series database. Why is that exciting? Well, we'll talk about that in a little bit, but we just open sourced it. So you can go right now to our website, and we're going to do that in a minute. You can download Riak TS, you can grab the source code, and you can start using it at your own leisure for free, and even terraform the code, see how we did it. So that's kind of cool. But under the covers, Riak TS is a highly available database. It's actually built on top of Riak KB. How many people have used KB before? It used to be the database formerly known as just Riak, but now we have to specify the type of database because we have three, KB, TS, and S2. No KB users? Anybody know about KB? I know some people answered questions. It's a key value database, highly distributed, designed to be clustered, so that if one or more of your nodes fails, you can still read or write. TS is exactly the same because it's built on top of KB, but it's optimized for time series use cases. It's scalable. We already asked the question, how many nodes is a cluster limited to? It's essentially unlimited. You can have hundreds of nodes of TS. Fault tolerant because nodes can fail and you can still ops people in the house? Any ops people? One? I know there's more. Oh, was that half-hearted? Really shy crowd. Surprising in the IT industry. I know we're all sort of glorious. But that's a big deal. If you're going to have 100 nodes of anything, it should be very easy to use, right? If you had 100 Oracle databases, how many DBAs would you have? That's a trick question. 1,000. So on the KV side, since TS is so new, I can only quote the KV side. We have some customers, like OpenX, who have over 500 nodes of KV in production, with 1.5 people responsible for it. And that's not the, I'm not making jokes. It's not a short person. This is a person. It's only a part-time job, so please don't get offended. It's just not their full-time job. All right. So the difference, though, it's KV, but optimized for time series data. This is really important. On the KV side of the house, you have a key and you have a value. Well, what we do is we hash that key consistently using the SHA-1 algorithm. We distribute your data around the cluster very evenly. That's great for a key value database, but it's really bad if you want to do things like a range query, because your data isn't co-located locally. If you ever look at a relational database under the cover and look at the data files, they're actually collated on disk or sorted. That's how you can do things like range queries on a SQL-based database, right? On a key value database like Riak, that doesn't work very well. It's very expensive to do. But what we've done in time series is we've actually taken the data, instead of distributing it evenly around the cluster, we distribute it based on time. And we'll talk about how we do it, but that's one of the keys to actually making that work. I apologize if you can't read this. I will read it off for you just so you understand it. How many relational database people do we have in the audience? Is that everyone? Almost everyone has seen SQL? This is a DDL statement that should look really familiar to people like myself who are old and have gray hair. This is what you do in Riak TS. Instead of having a bucket full of key value pairs, you create a table. That table has columns. Those columns have data types, things like varchar. There are timestamps, doubles, signed to 64-bit integers, booleans. I think I got them all. Okay. And then you have a primary key. And we're going to talk a little bit more about the primary key, but the important thing to understand is the primary key only requires one part. And the example I have up here, it's a 3-part primary key. So you can do a compound primary key, and you'll see that the fields in the primary key match the first 3 columns in my specification, my DDL specification. But the important one is the final bit, called the quantum. That is actually a function that creates a time range. So I take the timestamp up there, that column that's called timestamp. I'm setting the number to 30, that's the number of units. And the type today, that's the number of days I want that quantum range to be. So what happens, instead of distributing data evenly around the cluster, I'm distributing the data around the cluster based on 30 days, a range of 30 days. Make sense? So beyond that, not only does it tell me which node the data is going to live in, but on disk, it's going to collate the data based on that information as well. 2 things that allows us to do. It allows us to write data really fast to disk, but it also then allows us to do range queries over the data. And that's important. Time series is pretty useless if you can't query a range of data, right? This is the same table without the compound primary key, just pointing out that all you actually need to do is use that time quantum. Right now, you absolutely need to use time quantum. In the future, we're going to change that so that you can do things like maybe use a geohash. If you don't want to do time series, maybe you want to do based on a geohash. You could use the geohash. That's something that we're looking at adding in the future. But right now, we're Riak time series, so it's time series. I also point out that Riak KV and Riak time series are currently 2 different branches of kind of the same code base. And towards the end of this year, maybe the beginning of next year, they'll re-merge into one branch, so there won't necessarily be a KV and a time series anymore. It'll be one Riak again. That'll make my life a lot easier in trying to explain all this.
In your function, 30 days, you put them in one bucket?
Yeah, so it's not by bucket. It's a good question. It's how do we do this distribution? So under the cover, you might have 5 nodes of Riak time series. Within each node, you're going to have virtual nodes or partitions of data that are in addition to that. So on average, we recommend somewhere like 10, 12 virtual nodes per individual physical node. And the quantum range is the assignment to the virtual node or partition. So 30 days of data would go to one of those partitions, is how that works. And then once you've gone past 30 days, it moves to the next partition and the next partition. And that's an important point because when you're doing data modeling, the hardest part about Riak TS is to think about how much data you have, how fast that data is going to come in, and set the right range of time so that you're distributing the data evenly around your cluster.
I don't know where the 30-day interval begins.
The 30-day period begins when you write the first date.
So if I wrote the first one on the 21st of the month, they'd all be on the 21st from there on out.
Yes. So your first write establishes the start of that window of time. If it's the 22nd of March, then the 22nd of April is when you're going to get the next partition that's going to start getting read to.
So does it mean that for first month it will be written to one node only?
No, because we also do replication. That's a whole other thing. So within the cluster, replication happens. So you write a record and it gets replicated to 3 different nodes for backup.
But doesn't it create a hotspot? If my one node can't handle full load?
So if you make your quantum too large, and all of the data in that time series set that you're doing only goes to one partition, you would have a hotspot on one
But
node.
in any case, if it's real time, at given point of time, all my data goes to one partition.
Yes, if in the beginning, when you're writing all of your data within a certain quantum, they will all that data is going to go to one partition until the time goes to the next partition. So initially, in a startup process, you would have all of your data starting at one.
Why only start? I think each time, even if when it's switched to other partition, it will start writing to that other partition and stop writing to the first one.
It's when it rolls over the quantum, it'll go to the next partition. And really, I have to get her better.
So that would be another hotspot right there again.
The idea is to make sure that your quantum range fits your data set and the velocity of data. So over time, because remember, you're going to go around the cluster and you're going to keep going around the cluster and the partitions. It doesn't stop once you get around the cluster. So the idea is to make sure that when you're modeling the data, you model your quantum to ensure that you're distributing data evenly around the cluster over time. In the beginning, your data won't necessarily be evenly distributed, but over time it will be.
Yeah, so reads will be distributed, but writes will be local.
Yes, right. Okay, so the quantum ranges that are available to you, and that when we created the table, it was days. What we have is days, hours, minutes, and seconds. So it really depends on the velocity of data. So we did an example with a customer of ours who happens to be in the weather space, and you can probably guess if you look at our website who that customer is. We did a 15-minute quanta, and in that 15-minute time, we captured 1 billion records. So their incoming velocity is 1 billion records every 15 minutes. Just to give you an idea of the kind of velocity of data. We obviously don't have hours or years or decades because that would be a very large quanta, and there aren't a lot of use cases that that's very useful for. If your data is so sparse that you're working on the time frame of years, there are other products that are probably a better fit for you. So, in the time series world, Influx is super popular, and that is a great single node, single server product. They actually gave up open source support for clustering. But if your data fits on a single node, that's a really good option for you. This is designed for those data problems that are going to grow beyond that single node that you're going to need to be able to scale out.
What happens if you are receiving the data, you got an error, so how you can reindex or add the data that was created?
I'm sorry, I couldn't quite hear you. I want to make sure I understood.
What happens if the provider of your data, you can see have an error, and then you need to add that data next day.
Oh, so what happens if you get new records from past time series? You just add them and they will automatically go. There's no drawback to that. You can continue to go back in time and add historic records to a current data set. They'll just go to the correct partition for data, but that's not an issue. I think I already mentioned this, but these are there's varchar double signed 64-bit integers, booleans, and timestamps. The important thing to note about the timestamp, and we'll talk about this a little bit more, is that it's actually the Unix epoch. And that is really important because timestamps, as you're used to them, don't really lend themselves to lots of higher order math and sorting. So we want to use something very simple and numeric that's very efficient for sorting. Numbers are the way to go, but it is the Unix epoch, and we'll talk about some of the implications of that, and you'll see why it's important. We also use a subset of ANSI compliant SQL. This is also important because so many people here already know SQL. We don't have our own version of SQL. It is ANSI compliant SQL, and as we grow out the functionality, we're adding additional parts of the SQL language to Riak TS.
For your timestamps, do you support like milliseconds and microseconds though, or?
It is down to the millisecond because that's what the epoch supports. Yeah. Okay, so when we talk about SQL, here's a classic example of how you would query React, and we're going to show you some more advanced version. You'll see though that I am querying on the timestamp, a range between the timestamp and a number, because that is the Unix epoch. So when you use SQL to query Riak TS, you do actually have to convert to the epoch time. You can't put in a timestamp, right? That's an important note to make. And additional things that you should know is that we do allow you to use the following common equality operators. So equals, not equals, less than, greater than or equals, all kind of common equality functionality that you would have in SQL. And then on top of that, we add in some really handy aggregation, count, sum, mean, average, min, max. Standard deviation, we've got 2 different versions for the data scientists in the house because apparently this is complicated and not everyone can agree on what standard deviation means. So there's a sample and a population version. In a future version, hopefully by the end of this year, we will allow you to roll your own functions into React AV, but it's not quite there yet. They're working on building out the code base for that. So if you want to change how standard deviation works because you don't like ours, you'll be able to write your own eventually. And as of our release on Thursday last week of 1.3, we already had clients for your favorite languages, most of them anyway, Java, .NET, Ruby, Python, Node.js, Erlang, and PHP. Did anybody here do PHP? There's 1. Oh, no, those 2, sorry. 3. Okay. I won't make that still a thing joke. I'll leave that alone. And the one final piece, I'm going to move on in just a bit, but I'll also point out that beyond the basics, we support the aggregations, we support math and SQL, but if that's not enough for you because you really are a diehard data scientist or you have really big data problems that you want to munge over a couple million records, we have a Spark connector. And it's not an afterthought. This thing is built in to our platform, and it is also an open source component that allows you to then do those queries on TS and have RDDs out into Spark. So that's pretty awesome. I'm not going to show you that tonight because I think I can do most everything I need to do in Python and Pandas without the overhead of having a whole bunch of additional nodes of Spark running. But if your problems go beyond that, you've got Spark available to you. All right, so it is open source. You can grab it right now. Here is the address that takes you directly to where to get it. I'm going to pull it up, and I'm going to blow this up. It is so small on my screen, though. I'm not sure I can see this little button. Okay, that is. If you go to docs.basho.com, This is where you go as a starting point for all of the documentation and open source downloads. Hopefully everybody can see that. If not, you'll be able to find it later. But over here we have Riak TS. And then we have downloads. And this is where you can get your own favorite flavor. Now we run on Linux flavors in the Mac OS. We also have the source code, so if you're one of those people who likes to roll their own, you can absolutely do that. I almost never do. I've done it a couple of times for giggles. But what I'll tell you is, on the Mac, it's as simple as downloading it, unzipping it, copying it to your favorite directory. I'm going to pop this up hopefully quite a bit so you can read it. And doing React Start. So this is a cluster-based technology. In production, we recommend you have at least 5 nodes of any of our products running. Obviously, for demos, for playing around, for development, you can run a single node on your machine. And I just started. So I did React Start. I now have a running React. I can do React Ping. It's going to say Pong. That means it's running. There's a joke in there somewhere. Version. I want to make sure I'm running the right version because I have multiple versions on my machine. I can't tell you how many different Reacts I have. I think I'm off the screen over there. I'm sorry. I did not realize I was so far off the screen. It came back as 1.3.0, but apparently you can only see 3.0. Just to give you an idea that we are actually up and running, and I am running React on this. And the demos that I'm going to show you are running off of this machine. A single machine. That's going to be important when you see some of the things. So going forward what I'm now going to do is I'm going to talk about how to get started with this, because I told you what Riak TS is, and it's kind of boring. How many people are going to go and write some code on this later? Please let me see some hands, because I'm going to give you everything you need to get started beyond the docs, because let's face it, I don't read docs, which gets me in a lot of trouble, so I'm going to make it even easier, because I took a lot of the hard steps out of this, and it's easy enough as it is. But I'm using Python, and I'll be honest with you, I'm a Java guy. I did Java for years. I did C# before that. But just recently, I got really bored of Java and decided I'd try Python, and it's pretty awesome. So you need Python for these demos. Most machines have Python. How many Mac users in the house? It comes with like 2.7.11, which is old, but you know what? That's perfect. That's exactly what you need. If you want to go higher, great. You need at least 2.7.11. You're going to need the React Python client, which is extremely easy. If you have pip, all you need to do is pip install React, like that. I already have React installed, the React client, and so I don't know what it's actually going to do at this point. It should say, yep, already satisfied. It's all good. All right. So the other thing is pip. Let's see. So go from there. Jupyter. Anybody here use Jupyter? That is fantastic. You guys probably know it better than I do. I just started using it a couple of weeks ago because somebody at my company did a demo, and I said, that's really awesome. It used to be known as Jupyter Notebook. It's basically a web browser-based tool that allows you to enter code and play it back and run it. So that's what I'm going to show you the demos in. I'm also going to show you stuff in Eclipse too, because one thing I'll tell you is Jupyter can be really slow versus like native command line or Eclipse execution in code. So I want to show you some difference in speed. And then Pandas. I'm also going to show you Pandas. Anybody here use Pandas? You probably know more than I do as well. But that's beautiful. For those of you who don't, it's this really awesome data analysis library that does all kinds of complicated things for you almost for free. You know, you basically have to do nothing, and it's going to do data science for you. So if you're not using Pandas and you're using Python, or you want to get into Python and you want to do data science, this will make you look really smart really quick. By the way, all of the things I'm going to show you are also already on GitHub, so you can grab these as soon as this is over and you can play with it. Geez, this microphone is going to be fantastic to my nose. Who can't hear me? You're not missing anything. Yeah, I'm just gonna start shouting. All right. So first off, that is my GitHub repo home there, just in case you're curious. Can anybody? No. No. All right. On the bright side, now I can actually drop the mic when I'm done. That's a little bit messier, but that's the bit.ly link that takes you directly to the actual GitHub repo for this presentation and all of the code in this presentation. Can you guys hear me?
Yeah.
Yeah, you can put it down.
It's on.
Wow.
Yeah. I'm not a hardware guy. Hardware and me, we don't get along. This is is that better? I hear I think it's going up. Anyway, if you go to the first part, which is easy to remember, see Vitter, you'll get to the right place. By the way, if you don't want to do all of this stuff, I also have a Python, just a Python straight one that shows you how to use Python and all of the TS functionality in Python. There's also one for Java in case you're a Java person, but I haven't updated it to 1.3 yet because I'm not excited about Java at the moment.
Craig,
So.
can you hold the mic better? Can you hold it? I'm trying to help. I'm just trying to. Can you hold it differently? It's not you, man. There's nothing you can do. There's nothing you can do. It's not your problem. You're trying.
This is not helping my stage fright. Really starting to sweat now, just saying. All right. So with that said, most of the rest of this, I'm going to move away from this. I just like Dilbert because I'm an old man and it's funny, so that's why it's there. But now I'm going to move away. I'm going to pull up Jupyter. And the first thing I'm going to do, if you go to the code, so if you already use Jupyter Notebook, you already know how to use it. So you're going to go to the GitHub repo, and you're going to find a whole bunch of Jupyter files, and you'll be able to open those up and run them. But what you want to do is start with the create table. And let me see if I can blow this up to make it at least minorly legible. Okay. And I did actually put some comments in there. I know for us developers that's hard to do, but I tried to make this easy. So first thing you have to do is import the Riak client that you've hopefully installed using pip or one of your other favorite Python management tools. Establish the Riak client. Now the important thing to note is I don't have to do anything fancy with setting up the Riak client because it's a local node and it's just a local setup. But if you go to the docs and you want to connect to a cluster, you have to put in a little bit more information for a cluster. So that's why I put links to that stuff. I'm also going to work with a table called water meter data. So I just established that as a variable. I'm going to hit play. It runs that code. It's then going to the next block in Jupyter. This is really easy to do. Anybody not familiar with Jupyter, raise your hand and tell me to explain more. Does that all make sense? You can actually type right into your web browser and put code in. This is phenomenally weird and wonderful all at the same time. But once you've done that, you can execute it just like you're running code and step through the blocks. So here is my creation statement. We've already seen this creation statement. It's exactly the same one that was in the presentation earlier. So I hit play. It's going to take just a second because the code's executing, and then it's going to come back and it's going to tell me that that table was created successfully. Now, if you've already created a table, that's fine. You can run this repeatedly. It will not create the table again. It will send back an error that says, hey, I can't do that. I've already created that table. Move on, do something else. All right, and then the next thing we're going to do is we're going to just use the table description feature so that we can make sure that we created it and check what that looks like. All right, So that's what comes back from the table describe feature there in the client. I'm going to show you another feature. And I'm going to have to put down the mic for a second. This is where the handheld mic becomes a bit of a burden. Okay. All right, React Shell. This is a Riak TS REPL. Everybody know REPLs? All right. And what it allows us to do is actually type SQL in and live run SQL commands against React from the command line. So what we did was describe using the Python client.
So it's one server is running right now, right?
Yes, one server. Oh, semicolon. Gotta have that semicolon. All right, so I just ran from the REPL, described the same table, and we can now see what that looks like. So this is a fresh install of TS. I actually deleted my install right before this started, and I'm starting over from scratch again to make sure. I've done this about 20 times, so I'm hoping it won't blow up this time. But this is what comes back in the REPL. But you'll be able to also do SQL queries, inserts, and all that kind of stuff from here. I just wanted to demonstrate that while you can do it from Python and Jupyter, you can also do it here, so that's another way you can access that.
What's that 1, 2, 3?
Oh, yeah, so that is a fantastic question. In the primary key and the local key, you see the 1, 2, 3 value. That's the order of those compound keys, because I created a 3-part compound key. So number 1 is the first part, 2 is the second part, 3 is the third part. That's all it means. Those are the keys.
What's the primary keys kind of?
So the local key, the primary key is the partition, and the local key is the collation. It's the same. So the way that we partition the data is the same as how we then collate the data on disk. So partition, collation.
Does it mean that that will be your compound key, consisting from all these 3 columns in that order?
Yes. Because that's when we created the table up above, we specified right here those 3 columns, customer, meter, and timestamp as our primary key components. And so when we do table describe, we should see those in the same order that they exist in that key creation statement.
How do you know quantum parameters?
How do you know quantum parameters?
Yeah, from describe.
The quantum parameter does not appear in the describe statement. That is that it doesn't show up there. That's probably a really nice feature to add. That's a good question.
And timestamp actually will be integer?
The timestamp, yes, is because it's the Unix epoch. It's the number of milliseconds since the epoch. Okay, so now that we've created it, the next thing we're going to want to do is we're going to actually want to put some data in there because it's pretty useless without data. So I've got this write data function. Cool thing about Pandas, if you haven't used Pandas yet, is it's really got some clever features for doing things like parsing CSV files, Excel data sheets. So it's really clever at importing data. However, instead of doing that, I decided to fake up my own data and put it in here and give you some examples so you can create your own data set as opposed to having a bunch of additional files that you want to import. But what I'm going to start doing is I'm going to do some imports, some date time, the React client, our table name. I also put in this function here so we don't have to do this repetitively because I'm trying not to repeat my code over and over. This is a simple write function. So in this example, we have a table object, and we're going to use our React client to store data to the database. There are a couple simple commands here. I won't go into lots of detail unless anybody has questions. It seems like there are a lot of Python people in the audience, so hopefully you know Python better than I do, and that makes sense. Any questions?
Where is data to write?
The data. So this is a function, so that's going to get sent into this function, and we're going to create that down below. I also have some variables set up, like a start date to start where I'm going to start writing, some of the start values, and a couple things like this data set, which is just a list. I'm going to append to the list, etc. So I'm just going to execute that. Nothing's going to come back from it. But then what's going to happen is I'm going to do a while loop, and I'm going to create a whole bunch of records. In Python, what I'm actually storing is essentially a list, and now what I'm going to do is create a list of lists, and I'm going to save a batch of a list of lists. So I'm going to iterate. I'm going to create a year's worth of data, and I'm going to, over a certain time, I'm going to send batches, because Riak TS can do batch saves, and to be efficient, like 100 is probably a good number at a time. So like send 100 at a time, maybe not all 10,000, maybe not one, but you know, pick some kind of happy number that it will stop. And then I'm just going to iterate over based on different hours, and I'm going to change those values. So when we look back at the data and we do some analysis on this water meter data, we can see changes in usage patterns so that we can do some interesting munging on the data. So if you look through here, it's really boring. It's not very, I didn't spend a lot of time trying to make this sexy. But then what we're going to do is every time that batch count hits 100, I'm going to call that write data function that we have up above, and it's going to send that 100 records, and then it's going to do the next 100 records until they're all done. So I'm now going to write 1 year's worth of data, and this is where I'll tell you, doing this in any other way than Jupyter is going to be a lot faster. So when I talked in the beginning about how fast Riak TS is, so I'm going to show you how to do this here, and then I'm going to flip over to Eclipse, and I'm going to run the same code in Eclipse, because I want you to see the difference. All right, so it just finished now. That was roughly a minute that I managed to kill with talking about how fast Riak TS is. So if you scroll through all of these records, I printed them out so you can see all the records coming out. And it's going to take a while. It's actually 8,500 or 8,700, I forget the number. This is not the way to do it. Okay. Grab that. 8,785 records, all written to the database, okay? So if I flip over to Eclipse, go to write data. That took about a minute to do in Jupyter. This is going to be really hard to read, but what I'm going to do is run it. Okay, it's done. It takes 3 to 4 seconds depending on the execution time. It's variable, but you can see that's running on a single node on a MacBook Air that's got 4 gigabytes of RAM, woefully inadequate for anything other than PowerPoint, and it took less than 4 seconds to write those 8,000. Jupyter took like a minute. So a lot of the execution time is wasted by Jupyter. So if you're going to do a big data import, the lesson here is don't actually do it in Jupyter, do it in something else. Jupyter's great for looking at what happens, but it's really slow. But you can see I saved somewhere in the order of 3,000 records per second on a MacBook Air. That gives you some idea of how fast it should be, generally speaking. All right, so we've saved those records. What would we want to do? Let's see if those records are there. So we're going to do some simple queries on that. Again, we're importing our React client. This next piece, so remember when we set up our client before, this is a little bit different. So we're saving that Unix epoch, which is a number, it's not actually a date. When you deal with these dates and you query back, you actually have to tell React if you want to see it as a Python date. There's a little parameter here that says pass it back out as a Python date and not as a number. So I did that because I don't really want to see the number, especially for data analysis later. So I want to make sure that you guys have that information, because otherwise you're going to see numbers coming back. And a lot of times I'm dealing with dates, especially when we start looking at cool things we can do with the data. So run that block. And then I'm going to do a simple query. So if I want to query based on a specific record, I can simply pass into React that read part or one part, whatever your primary key is, you can pass the primary key in using the client.tsGet function. And this is what React's going to return in a Python client, a list of those fields in the record. Very simple to get a single record back. Most of the time with Riak TS, you're not going to do a single record. That's a pretty rare operation because it is a time series database. You're going to want to do some kind of query. So what we're going to do is we're going to do a range expression with a start date and an end date. And I mentioned this before, but when you use SQL, you need to convert the time to the Unix epoch, right, to the number. This is a really ugly way to do it. Later on, I simplify it down to a function, so if you steal that function, you can reuse that function over and over again. But this simply takes the date and converts it into the Unix epoch. The better way is to have a function that you can reuse to do it. And then I create a query here where I select asterisks from that water meter data table, where the timestamp is between this and this. And then one thing you should know is if you have a three-part primary key, when you do the query, all three parts of the primary key need to be part of that where statement. You can't do only one piece of it. You always have to query on the time, but if it's a three-part key, you also have to query on the other three parts of the key. And they actually have to be equality statements. They can't be greater than or less than statements. So if you only use the time as your primary key, then you don't have to query on the other three components like I'm showing here. And then you can use those components as further filters and use other equality operators. They don't have to be equality only. Does that make sense? Because I just use equality a lot, and I'm hearing that, and sometimes I'm thinking, did I just totally hash that up, or did that make sense? I mean, I'm hearing one thing in my own head, and I don't know if it's what's coming out.
Does order matters in the primary key?
What's
Does
that?
order of columns matters in the primary key? Because you can have timestamp as the first one or timestamp as the last one. Doesn't matter.
So the timestamp always has to be the last part of the key. It can be the only part of the key, but it has to be the last part. It can't be the middle part or the first part.
So this doesn't look like real SQL. This is some kind of manufactured stuff that is exactly matching your key structure. I mean, it's clear why you're doing that, because you need to manufacture your key. And you're using SQL as a kind of very superficial outer kind of like construct. But you know, I mean, if the language mandates that, it's not SQL.
It is actually, the SQL itself is ANSI compliant. So you can create in any SQL table a structure and use the same actual select statement.
Right, but in case the meter ID, for example, will be omitted here, if meter ID will not be present in that SQL, your SQL will not run.
That is correct.
Because you will not be able to construct your key in order to get your value.
Yeah, so if you don't, in this case with the three-part key, it won't actually, the SQL will fail to return a value. But it's still ANSI compliant SQL, it doesn't make it non-ANSI compliant.
But it's so manufactured that
Okay.
Is there no other way to query it other than using?
So again, if you only use the time as the primary key, you can use other filters. You can filter on other columns. It's only set up this way in this query because I use the three-part primary key. And so we should talk about that, because from a data modeling perspective, why you would use a three-part primary key versus just the time, which would be more flexible, has to do on the query patterns that you're going to use, both from a write perspective and a read perspective. So when you think about how you query data, if you're always going to query data based on those three components, it's much faster to set them up as a three-part key because of the collation factor and the partitioning than to only use the time. Now, if your queries are going to go across customers and meters, and you're never going to query in this pattern, then you would only use the time. So you have to think about your query path just like you do when you set up a relational database in your schema, because many relational databases allow you to do multi-part primary keys. And you do that based on your query patterns for performance reasons. So that's something that you have to keep in
A silly
mind.
question. Does primary key have to be unique?
Primary key, yes, primary keys always have to be
Because
unique.
that's one of the reasons I may want other things, because I can't guarantee timestamp would be unique for two different sensors.
Correct. That would be another reason, because the Unix, it's only a millisecond. So a timestamp, conceivably, if it's a water meter, you could have 100,000 water meters all kind of phoning home at exactly the same time. Now, they'd never be exactly the same time, but it could, at least 10 of them would be, right? So that's another reason, sure. So anyway, we've set up our query. We're going to run that query. I've printed out the query so you can see what it looks like as far as the timestamp generates. And then it's going to return a set of rows based on that. And it looks exactly like the single row, except we have a range of rows. And in this case, I have 721 rows for that query that gets returned. Now we're going to use that same query, and the only thing I'm going to do is I'm going to change it to add an additional filter just to show you that I can take one of the other columns in that table and filter on it. So it's the same query, but just with the further filter showing you only those records that have a fault condition in them, and there's 7 of them. 7 out of the 720 are going to have fault conditions. Taking that one further out, once we want to go into doing aggregate or math type of data on them, we can use this example here where I'm doing the same range of time, but what I'm doing is taking the max total gallons and then subtracting the min total gallons. So if this is a range of a month, I can see the total gallons that have accumulated over that time span. The average water pressure that meter is telling me they have, and the average gallons per hour that they're utilizing, and print that out. So that just shows you very simply how you can use the math and aggregate functions and actually combine math and aggregates at the same time, which makes it very easy to query and do something useful for it. Now, one of the things I'll tell you, common question we get with these types of things, and we do a lot of time series on KV as well, is does TS do automatic rollups? Because when you're doing time series, people start thinking about aggregates and rollups, and the answer is no, but it's really easy to do with that kind of functionality. So one of the examples I set up is this create rollup table file. Again, we're using the Riak client import, but I'm adding a new table here called water meter monthly rollup. That table is going to have a lot of the same fields, but we're going to have a reading date. So on a monthly basis, what you do is set up some kind of cron job that runs this, goes through all the meters, and takes a reading for that month and adds it to the rollup table so you can have billing. If you get your water data, it usually shows you over the last 6 months what's your water usage patterns, that kind of stuff. It makes it really easy to generate. So I'm going to create that table. And you'll notice, as an example, I actually used just the one part key here. So you can see what it looks like to use a single part key. In this case, we're probably not going to query data only based on the customer or the meter. What we might want to do is query all of them, right? This example isn't really good because they're all going to have the exact same date. So you will have key collisions, and you have to keep that in mind. But just to show you that you can use a single part key.
What does it mean 3,000? 3,000 days?
That is 3,000 days.
So that means everything goes into one.
Well, over the course of decades, it would span out. But just as an example, there's only 12 records in this data set that we're going to generate, so it doesn't really matter. But you can adjust that number. There's really no limit on what you can make it.
Another question about the writes. I mean, how many writes are in reality happening here per second? Let's say per second. You showed even in the clip something like 8,000 records were going into like
In under 4 seconds.
4 seconds.
Right. So on this individual
so it's about
machine,
2,000 writes a second. I mean that sounds, very very low number.
On
I
a-
mean, some systems are doing hundreds of thousands and millions of writes per second. Is that
I actually think that 3,000 writes per second to a database on a 4 gigabyte MacBook Air is pretty good. And testing we have done with much more realistic cluster sizes, depending on the.
But what will happen on the realistic cluster size? Because if you show there that everything writes into one partition because it writes, let's say in reality, at the same time when these gallons are happening. So there's no parallelization in writes. It's everything going into one partition. It's like this gentleman said, it's 100% hotspot. And then even if it will be rolled into another one, there will be hotspot there. I mean, this is like, you know, glaring example how you manufacture hotspots.
So
Looks to me. I don't know.
I actually have a question to this. If we have multiple sensors, will each one has its own partition, or there will be same partition for all of them?
So if you write to one table, all the data is going to go to
Yeah,
the
it's
same
according to
place.
No, I
timestamp.
think if it's
It's
different
according
sensors,
to timestamp.
you have the 3 parts keys.
But first two parts do not matter because they only, you know.
Let's move this question to, guys come up to me after and we'll talk. I can explain it. So I'm just going to run this scribe, and you can see that I created the table. This is handy just to show you created. I'm going to move to the next step where we're going to actually write those roll-up records. Here's the simpler function, convert to epic, so that you can steal that to use it. What I do is I loop over that kind of summing I did before, and then I just write those records to the roll-up table. So those are the records I wrote, and then I can then do a query on it to show that I've written those records. That's just a really simple way to describe how you can do some of those roll-ups, those aggregations, which are handy for time series, because at some point you don't want to continuously ask the same questions over and over. You just want to save that information so you don't have to worry about it. So that's kind of when we get to the next step. Pandas. What is Pandas? The visualization and data munging library for Python. So I'm going to kind of go through, and there's some really good examples out here too. I would take a look if you're new to it. A lot of people here already know it, but there's a 10-minute to Pandas, which gives you a great overview, which is why I linked it here.
I just have one question. Does this database allow to update the rows?
So that is a fantastic question. We always say that Riak time series is designed for immutable data, which you would think means you can't update the data. However, you saw that I wrote the data in Jupyter, and then I wrote it again in Eclipse. It was the exact same code executed in 2 different places. So the answer is, it's immutable data that you can update.
What's the answer?
So yes, you can write over the data again. You can update the data.
So it is mutable.
It is, yeah, it is mutable.
It's better if it's better if you don't do that.
Yes. So most NoSQL databases, and Riak TS fall into this, it is a append-only data store. If you continuously write that same data, it's append-only, so you've got the record multiple times, and eventually you will have a compaction event, and the old data will go away. But it is an append-only data store, but you can update it. It's not an update in place.
And so what will happen if the key is the same and the value is different, and you write and there is already record in the database?
You get
the
the new
old
value.
one will be wiped out right
Yep.
there at the right time?
Yes, in TS that is correct.
So and your insert statement won't complain because you had insert statement in Eclipse, not update.
Yes, so we also have a SQL insert statement, and that is it is an insert or update. It's essentially, it does the same. Yeah.
Can we go update a single field in the record? Is
Uh,
that an update statement that you can?
No.
So that's why it's immutable in that sense.
All right. So what I'm going to do is you see I'm importing Pandas. So you have to have Pandas installed, importing it, grabbing our water monthly rollup table, converting the epic. So one thing I'll tell you is Pandas has, they have data sets, they have data frames, and what we get back from Riak looks like a list of lists. And normally you can convert a list of lists to a data frame. But what Riak actually sends back is a TS or time series object. It looks like a list of lists, but it has some additional details to it. So this function here is just a really nasty, like quickly munched together function that converts the TS object to an actual list of lists, because a TS object does not load into a Pandas data frame directly. And we're going to work on what's called a data frame, because a data frame gives us all kinds of built-in functionality out of Pandas. So what I'm going to do is I'm going to retrieve that data from our rollup, like I did before. I'm going to then convert that into our boring list. And once I've done that, I'm going to do a couple of things, because I want to do some data analysis. I want to print it out really pretty. I want to have an index on the data. So I'm going to actually call out the name of the columns. I'm going to add that to our data frame. So the data frame is like a list of lists, but beyond that. So I'm going to actually give it column names. I'm going to give it an index. I'm going to index based on my date. And then I've got df, which is my data frame. And when I run that, look what Pandas does for me. Let me zoom out a little bit. No. All right, so, oh, there we go. Just took a second. That's the other thing. If you're running, if you have lots of running Pandas code, your browser might start to get a little slow. So it pays to kill off a few. But you can see just automatically Pandas will print out a nice, pretty format of our data set for us. And when I did this before with just getting data back from RiakTS, it wasn't pretty. It was just a list of lists I was outputting, right? So that's a nice feature. There's a lot of cool stuff built in to Pandas. So this next one, I'm only going to grab the one column, which is the gallons. Just df gallons, and that's what it returns. It returns the index of the date, and then the data for the gallons tells us what type that is, float. The next thing I'm going to do, this is also cool, if you're going to do a large data set, you can grab a snapshot of that data set. So in this case, what I've asked for, up there, let me zoom back in so you can read it better. By date, by that index, I've asked for March through June of the data set. So it's only giving me back a couple of rows based on what I've asked for. 4 gigs of RAM, I think I'm running out of all of those gigs. So like 0 left. Some other features, so I talked about indexing based on the date. I took that date column. So if I want to check what my index is, there's the actual fields I'm indexing in. So if you need to know the index in your data, you can do that. I can output the columns. I can output the actual data values if you want to see them in ugly array value format. Information on the data frame itself. What are the columns? And interestingly enough, what's the usage memory-wise? So one of the things to keep in mind is if you have a very large set of data, you can overflow the actual memory on the machine. This will give you some idea of that, and you can go into a little bit more information and find out what the columns are using individually as far as the data size. Describe is pretty cool. This is when we get into some actual data science. So without doing any heavy lifting, you can say describe. Describe is going to bring back your columns and give you things like count, mean, standard deviation, min, max values, and everything in between. Boom, you're a data scientist. That's pretty cool.
How do I have custom functions?
So there's way more than this. There's almost, I'm not a data scientist, I said that from the beginning. There's stuff that it does that I didn't put in here because I didn't actually know what they meant. But yes, you can also add custom functions in there if you need to. Count, min, max. I'm going to skip some of that because we've gone through some. Really cool things you can do, things like grabbing and sorting. So we can take that same output and sort it by different values that we want to do very quickly. Group by. So if you want to group by specific values. And this is where it gets really nice for folks who are used to having to do a lot more effort around plotting data is we take the matplotlib library, add a little statement in there so that it runs in line in our actual Jupyter notebook. That's very important. If you don't add that little statement, you won't actually see the nice graph. It'll just print out this line right here and nothing else. So you need to add.
But with it launched another window, like the graph gets launched until it's
Not on my machine, it never works.
Until it, that's what it's doing.
Okay.
Oh, but yeah, then wait till it's ended, and then it pops up the other window. That's the way.
But if you want the graph to show up in this window, you definitely have to increase that, add that line, and it will automatically drop. And look at this. It knows what the fields are based on your column headers in that. It knows what it should add as far as the axes, the labeling them. So like numbers, the dates, etc. It automatically knows how to put those in. Beyond that, you can go to the next. I should probably kill some of these off before my machine bursts into flames. So you can just select all these and hit shutdown. We'll free up some of this here. And then I just have a few more quick examples on the visualization side, where I grab that data again, and then you have some capability in here to change different things, like what are the axes labels, what are the sizes, that types of things. So you can very simply do visualization. Real quick way to take data out of a database like TS and do visualization and do data science on top of it. So that said, what I hope is that you now have some tools so that you can actually download TS. If you're already using these tools, you're way ahead of folks who aren't. It's only going to take you a couple of minutes to get up and running on TS, actually execute this code, and start play around with it in your own environment. So with that said, that took way longer than I figured it would. But this is going to take like 10 minutes. It's just so basic. I'm going to like run through that, drop the mic, run out of here, find a bar, drink heavily.
So question I have is it portable to multiple platforms like Windows, Linux, Mac, Linux?
Our supported platforms are specifically for production. If you want to run this in production, we support Ubuntu, CentOS, and RHEL. You can roll your own on other Linux platforms. It runs on the Mac. It does not run on Windows. We don't support Windows. It does run on VMs on Windows. If you're an Azure customer, we actually have customers on Azure, but just not running Windows. Sorry.
No problem. Before we take more questions, so first I want to give a great round of applause to Craig Vitter. And we are giving away in a few minutes a $100 Amazon gift card. Did everyone have a chance to throw a business card in here? If not, tell me now. Nobody. Okay, so we'll give that away. All right, so take it, pass it around. So let's take another couple questions, and then we'll give away the gift card. Yes.
I have a really simple question. Does this code work with Python 3? Do you support Python?
The code should work in Python 3. I have just been too lazy to upgrade from 2.7.11. I believe it all works in Python 3. If it doesn't, please submit a pull request. I will gladly take pull requests. I put out a Python example, a separate repo of Python examples. Somebody immediately did a pull request and like prettified it for Python 3. And I was like, sure, I'll take that. So I put the code up there, but if you want to change anything, if you've got suggestions, please feel free. Love it. I don't feel like I own it.
Yes.
Do you have the feature of TTL in RiakTS?
We do not have a built-in ETL function in RiakTS. However, I think hopefully when you look at the code, you'll see how easy it is to do, and there are a lot of tools that could be quickly made to do it, like Pentaho and that very easily.
What are the real live production applications that are running right now with RiakTS? So what are the use cases that they're trying to solve?
So that's what real life use cases are we going? So we released our first version in December, and we just open sourced on Thursday. We have one customer in production on enterprise version of Riak TS, and I can't tell you what they're doing yet because I don't actually know what they're doing. We are in testing with some very large customers. Like one of our big customers, and you can find this out from our website, is the weather company. They use Riak KB in a massive way, and they're using, they're testing TS for time series use cases, but it's specifically the large volume ingest of raw weather observations from the tens of thousands of weather stations that they get observations from.
You mentioned,
Let's get his hand up.
Do you have in the documentation example how to deploy in a cluster or no?
Yeah, good question. So the documentation certainly does talk about how to cluster it. It's ridiculously easy. I've shoulder surfed recently on the phone while people did it and talked them through it. And I hate shoulder surfing, especially on the phone. It takes no time at all. If it takes you an hour to do it, that's because you're reading the documents. The second time you do it, it'll take you like 10 minutes. It took us an hour because, well, the other thing is we had to walk through like setting up security on CentOS and other things. You know, that's usually the hardest part. It's harder to do that stuff than to install it.
Last question.
you mentioned earlier OpenX as a user of the React.
So OpenX uses React KB. They don't use time series yet. They're a huge user of KB though. They actually have some, if you're interested in stuff like ops from an ops perspective, if anybody here use SaltStack? A couple of people. They had a really good piece out they did about how they manage KB installations with SaltStack and that. Because they have hundreds of nodes. They're the kind of people that 10 nodes fail because of hard drives, and they just wait until the 11th one fails before they start replacing it, because they have so many. But they haven't used TS yet.
One quick follow-up.
Yeah.
Any issues using React with Anaconda? Like if you're using like the Anaconda download to bring up Python and all those other libraries?
I honestly don't know the answer to that. I am such a Python noob that
Anaconda is a great way to just pull down all of that stuff in one shot.
I would have to check that out.
We're out of time for questions, but Craig will be here
Yeah.
for one-on-one questions right after. Let's do a raffle. Can I ask you to just mix it over? All right, now look that way and reach in and grab one out. You read it.
Oh, great. This is Salilia Wong.
Salilia Wong?
Salilia Wong? Yeah.
Right
Yeah, no, wait, no, she's right there. She's just being shy.
Oh, you.
That's her.
Oh, okay. Congratulations. Craig is here for one-on-one questions. Thank you all for coming. Thank you.